All right. Hello, everyone. This is hexInject and hexDSL workshop. Basically, we had the workshop prepared to be fully hands-on, but so the first slide is really how to set yourself up. It should be fairly easy, but we will go through the solutions of the exercises. We will do it. We will live code that thing here, because not everyone wants to use laptop and so on. So you can, if you want to follow along, feel free to do those things. Basically, you just clone the repository, and there are folders, and each folder is basically self-contained project. So the project is fully unit tested. There are basically empty methods with to-dos of what the exercises are and what you should do. And you're writing the code against unit tests. So if the solution is correct, the test will be green. So in the beginning, everything is failing all over the place and everything is screaming, assertions are wrong, and so on. But eventually, by the end of the workshop, everything will be green and working. So let's start. My name is Stepan Vyterna, or Steve in short. This is Laurent. He's going to do the second part of the hexDSL. And we're going to start with hexInject. First, who's somehow familiar with dependency injection? Like, all right, everyone, basically. So I can very briefly stream through the basic theory. But yeah, first, hexInject. It's a dependency injection framework, as it's obvious from the name. And if you look at this diagram, this is Hex Machina, basically, which is really large set of different modules and libraries, but each of them can be used separately. So you don't need to buy in the whole ecosystem. You can just use one part and it's going to work. So today we're going to use just hexInject, which depends already on plenty of other pieces, but you don't bundle in all the MVC framework and so on. You just have the plain dependency injection. So what the dependency injection is, it's basically, what is the dependency? That's an object or service or something that can be used by something else. An injection is basically you put that object somewhere. In a sense, that's pretty much it. What Francis talked about before lunch is the dependency inversion, where you don't construct things yourself. You basically depend only on things that are supplied to you. And dependency injection is a way of how to supply the dependencies to you, to your class, to your module. So why would you want to do this? Mainly because if you manage everything yourself, if your classes are constructing new objects or if they are calling something static to get objects in return, you already know the implementation, so you can't easily exchange that. You're literally tying yourself and coupling to that given implementation that you're calling, and that's it. And that's one thing. And the other thing is, if you have large object tree and suddenly something that is very low needs an object that is only accessible from the higher scope, you have to somehow bubble it through the whole tree so your object can have the dependency that it actually needs. Dependency injection is solving all those problems. Basically, all the things are available based on whatever rules you create, and you can write against interfaces, so you can exchange the implementation quite easily. So yeah, what is the dependency injector actually? So it's basically an object, a container that holds instances of other objects and provides them when you actually need them. And it doesn't really hold the interfaces or the instances directly, but it works on somehow rule-based system. So it holds a rule which then provides the given object. So there are basically two sides of each dependency. First, you have to map something. That way you expose it to the injector, and then you request it. So we're going to go through both of those sides. First, the mapping. It is this is fairly standard API. Basically, you say, I want to map a type or interface to something of a type or an interface. Example is a singleton. So you say, I want to map this interface to a singleton of whatever, and that means when something asks for X, for that one thing, the injector knows that it should ask the rule which creates the singleton to return the instance of what the rule is holding. And getting stuff from the injector, that's quite straightforward. You just ask for it, you get whatever the injector has based on the given rule. So what are we going to do during this whole workshop? We will map things and let the injector manage all the instances. We will create our own rules, our own dependency providers. We will know how to request stuff from the injector, all the different possible ways. We will know how to do annotations as well, based on what the injector supports. And then there are details about how when, for example, singleton is managed by the injector, there are some rules about the life cycle, like when the instance gets constructed, then you want to do something. When it gets destroyed, you want to do something else. So let's start with mapping the dependencies. First there are various types of mappings that are built in, and you can of course extend. So first is value mapping. Basically, it is the dot to value call, and that basically means when something requires my class, just give this instance and that's it. It's basically a singleton that you construct yourself. Might be a good idea, might be bad idea, depends on your setup. For example, you might want to expose, say, physics engine, which isn't like modularized, but you have to create that and then you expose it to the injector. Injector then manages everything, and you can then inject the physics into anything and do things. Singleton mapping is basically the same thing as value, except for that the injector is actually constructing the instance. There is one advantage and disadvantage at the same time. It is constructed lazily. So only when the first thing requests that given dependency, the injector creates that and supplies that instance. But if nobody asks for it, it's just a mapping. The instance doesn't exist. It's not constructed, not running, and so on. So you might run into issues that you map to singleton and things are like, yeah, this rendering is not running even though it's mapped. It's because it's not constructed. Then there is type mapping, which is the dot to type. It is basically a factory. You will get a new instance of that given type whenever you ask for an instance. This just keeps creating new instances forever. And more often than not, you have multiple instances, for example, like multiple singletons of the same type, which you want to expose, but you need to make a difference between them. So, for example, you have player controls, like you have the local player and the, remote player, and they both have the same interface, they both communicate exactly the same way, but you need to differentiate between them. And there, the named mappings are coming in because you can, everything you can map, you can attach it a name, which is just plain string. And then when requesting that given instance, you get it by the name as well. So you can, this way you can manage n instances of the same type while still keeping things fairly encapsulated because you refer to them only by their names. And then, of course, like when you map things, you have to have a way to unmap things. So fairly straightforward, you just unmap and that's it. There is a second optional parameter is the name. So if you map something with the name, you unmap it again with the same name. It just removes it destroys the dependency provider, which can do things to the instance it's managing. I will talk about that later. So now we're arriving to the first exercise. The exercises are themed. They are Rick and Morty themed. Who's familiar with Rick and Morty? All right, brilliant. For the ones who aren't, it's a animated TV show from Adult Swim. There is the main character, Rick, is a crazy scientist, most intelligent person in the world, and highly functional alcoholic. And he has a grandson called Morty, who is 14, really insecure about things, and he's helping Rick to solve crazy adventures all over the galaxy and multiverse. So let's move on to the first exercise. We can give a moment for the ones who want to try things themselves. And we will go through the exercises for you as well. So basically, currently we're going to be working with just the mapping exercise hx. For now, forget about the file that is _1. And here on the cheat sheet are the methods you will need to solve all the to-dos that are there. So yes, let's go through this. So the first one is quite simple. So in this exercise, you will be just mapping things to the injector. So the unit tests are actually requesting stuff for you. Every method in this exercise is separated. So when you map something, you don't have to unmap it later and so on. Everything is isolated. So whatever you do in one method, it doesn't influence anything else in another method. So let's go with the first exercise. So every time you ask for Rick, you should always get the same one. Well, that's a singleton. There are two solutions for this. Of course, as usual, you first can just create new Rick and assign it to something. Yes.
Please adjust the make a little bit bigger.
Yes, sure. I already increased this. Where's plus on English keyboard? There you go. Scroll bar for the win. No worries. So yeah, you have English.
Yeah.
So we can just assign it, or we can just injector.map. Yes, injector. So we can just map the rig to itself. So we can do. Yes, this is Windows. All right, I will do that. So you can map it either to value, but then you have to create new rig, which you did to my computer. There you go. So this if we compile that, the first test in theory should be passing. Yes. This is gonna pass because there is no way for the test to know if the mapping was to singleton or to value. You can as well do the same thing. It's gonna pass if we just do to singleton and we just give it a Rick type. So if we comment this, let it run. Where we are, Rick is the same, so the test passed as well. So here, this basically is up to you. If you are comfortable creating new objects, you can.
Why need to move the class twice? Once in the map and once in the singleton.
Because in the map it doesn't have to be the same class. It can be interface, for example. So this one it's simplified example. So there the class the thing you're mapping to is the same as the type that you will be requesting. But in later exercises there is actually there is a difference when you map something to an interface, and you can as well map one thing to multiple interfaces as well. I will talk about that later. All right, so Rick died, so we need to get rid of him from the injector. So that's just unmapping. So we can just unmap Rick, and it's gonna be okay. Alright, assertions count is going up. So one of them is Rick died, hopefully. Should be somewhere. So that should be passing. So now we actually have two different Ricks, because they are from different universes, but they need to coexist at some point. So we need to create multiple mappings of multiple instances, and they are all going to be singletons. So we map Rick with the name C137, which is Earth. To singleton or to a new instance. So let's go with the singleton. That one's less typing. To singleton of Rick, and then we need a second Rick, which is from different universe. So it's obviously going to be a different instance, and this thing should start passing now as well. So the past assertions count is getting up, and yes, Ricks from two different realities are there. And here we have, so here is the case when we have one Rick, which is who is a scientist. So he can act as his own role. So because he implements an interface iScientist, you can just supply Rick whenever someone asks for a scientist. So we map again, and now we need to expose scientist. So we map iScientist. To again singleton of Rick, and this is answer to your question, because this way you can actually say in the code nobody knows that there is any Rick. There is whatever, some research facility that works with scientists, and they don't really care who are the scientists. So this way, it's gonna this thing should be passing, right? Eventually, somewhere. We are number 4. No, 3. Yes, passed. Next one. There's a thing called music box in the TV show. It is basically a magic box where you press a button, it creates a creature. You tell the creature a simple task to do. The creature will fulfill that task and ends its own existence. So clearly you need a factory. You need to create multiple of those creatures that have single purpose only, and then they die. So we create a mapping for IME6, and we need to supply the type mapping because we need every time new instance. So we map it to type of Me6. There should be one without interface. Yes. So this one should be passing. For it was there. Yes. Passed. All right. Next one. This is the case when basically Rick is a scientist and he's also grandpa. So like certain set of population will refer to him as a scientist, but Morty and his sister, they will refer to him as a grandpa because he's their grandfather, and that's what makes sense for them. So here Rick implements 2 different interfaces. So you can map iScientist to Rick as we did before, so to singleton of Rick, and we will do the same thing for the iGrandpa. Yes. And now if we run this, you will see that this test is failing because the Ricks are different, and that's what happens because when you create the singleton mapping, it creates one provider which holds one instance. You create another singleton mapping which creates another provider which holds another instance. So now this code is actually producing 2 instances of Rick, which they both act as one interface, or as like they act separately. But there is only one Rick, so how do we fix that? One way out of this is we can create the instance ourselves, so we will just create new Rick and map to value both of the things, and then they will share that one instance. So instead of to singleton, we will do to value. And this test should now start passing. Yes, all the first test suite is done. There should be nothing more. All right. So this was ways to map things. Any questions so far? Nope. All right. Good. Mapping is done. So as I said, there are things called dependency providers, which are sitting under the surface, and that's what, when you ask Injector for something, that's Injector asks the provider to actually provide an instance. So for example, if you do dot to singleton, it's just syntactic sugar for create singleton dependency provider and map that thing to a dependency provider. Dependency provider itself is fairly hard to describe because it's hard to avoid describing the dependency provider without using words dependency and provider, because that's exactly what it is doing. Like it literally, you ask it for something and it will give you an instance back. So there is I will get to how the provider actually looks like in a minute, but let's go back to the mapping. There is another method for the mappings. It's to provider, and you can just put there instance of your provider, and that's it. Like the injector will just automatically start working with it. You can do whatever you want. You need to only implement the dependency provider generic, so you need to supply the type that you will be actually returning, and then you can just throw it in the injector and it's going to work. And yes, the dependency provider is an interface which has two methods. One, the more complicated one, is the get result, which is called every single time when something needs an object. So you do injector get instance, or you use metadata or anything, it will call this method on the dependency provider. It has two parameters. One is the injector that is currently in charge of supplying the dependency, and second one is a target, which is class of the thing that is requesting stuff from you. It is a class, not an instance. So you, because it might have dependency in a constructor, so it doesn't exist yet when you are creating your objects. So you just get only the type that requires it, and you can use all those informations. So for example, the reason why you're getting injector is because you can have one provider. Since you're mapping it as instance, you can have it in multiple injectors, and all of them will just supply themselves in case you need some additional objects for constructing the object you want to supply. So yeah, for example, the singleton dependency provider will construct dependencies of the singleton that it will build from the injector that is supplied here in this argument. And then second method in that interface is destroy. That's pretty straightforward. It is basically when you call unmap, and the whole dependency should cease existence. So for example, the dependency provider will assign to now remove all the stuff and calls destroy if it is necessary on that instance, and just gets rid of it and make it ready for garbage collection. So let's go to exercise 1_1, because this is more like advanced part for creating things. Here on the slide that's example implementation of how such dependency provider might look like. In this exercise, we will be creating two different dependency providers, each for a different purpose. So let's do it. So mapping exercise _1. All right. This also those exercises will require slightly more work. We will need to create classes because we need to implement that interface and zoom in. Yes. All right. So first problem that you might get is you want to know how many things your factory created, for example. So in this case, we want to know how many meseeks were created by the meseeks book. There is a way to do that. You use static property somewhere, and in each constructor you can count, increase the static property, but then you have the static property, it's somewhere, and it starts, you're cluttering your instances with things they shouldn't care about. A way to do this in using Injector, using your own dependency provider is that we will need to implement the create provider. So
Do we have some support or?
no, not really. Just create it in the same file.
Okay.
Just at the end, we'll make a new class, say me6 provider. You will implement the iDependency provider interface. The one below. Of type me6, so you need to give it the generic. So this is necessary so we can leverage the hex type checking. There are frameworks that don't do that. You just return dynamic or something like that. But yeah, here you can Control-Shift-1. Yes.
Wonderful.
So this thing will actually give you nice generated code. So there is in the README is we should also implement counter and keep the count. So implement the iCounter interface. Yes, and that just has count. So in the getResult function, we now need to produce the me6 and return them. We can do it from the injector, or we can just return new Mr. me6. So you can just return it, and that's it. Alright, now we need to count them. So you create just some variable, call it counter or count, doesn't matter. It's gonna be int. Probably initialize it with 0, and in the get result you can you just increase the count, and that's it. And so suddenly, without any static property anywhere, you are counting the amount of instances you are creating. You return it in the get count, because that is necessary for the exercise. All right. So we have the dependency provider, but we need to create the mapping. So in the first exercise, you create just new instance of this provider. Control-Shift-1. Assign it. There you go. You return that one, and you still need to create the mapping because this thing is returning it just for the counter. So we do injector map, and we map the me6 because that's what we want to provide to provider, and that's the instance. So yes, this should now start passing, at least the first one. If you make a mistake. What?
There's no constructor.
Yes, there's no constructor. Yeah, and that's again, you can use Control-Shift-1, generate constructor.
Okay, let's try.
It's
hexdevelop is wonderful.
yeah, hexdevelop does its job. Yes, now it should compile and run. All right. Let's have a look. _1. There is, yes, counter counts. So yes, here you are basically not polluting anything in your instances. You're just adapting to your new requirements. The me6 still does its job. You don't have to throw in additional logic to keep count and so on. You can do it somewhere else. And if you have the injector through the place, then you can leverage this power that all the instances are created through that. Another way to use the injector and leverage the power of the dependency provider is if you are if the object you're supplying is context dependent. So in this case, in this exercise, there are multiple people asking Rick for an answer, and he's usually helpful except for Jerry, who's husband of his daughter, and he really doesn't like him, so he just insults him all the time. So in this case, you want to check if you're answering to Jerry, and if yes, then you provide an insult. Otherwise, you just provide any answer possible. So we create a new dependency provider, again, call it like, I don't know, answer provider. We implement again the iDependency provider for iAnswer. It is not there. Yeah, constructor, so we don't forget that one. Implement the methods. You need to be in that interface. No, there, yes. So in the get result, we need to check if the one who's requesting is Jerry. So there is a helper method. You just do if and Jerry dot is Jerry. There is a static helper to check whether or not a class is Jerry. So you just check the target. And based on this, you either return, if it is Jerry, you return new insult. Otherwise, you return a new answer, basically. All right. Remove the semicolon and assign that to create the mapping. So again, injector.map, and we don't need to return this thing, so we can just assign, put it directly into the mapping anyway. So I answer. That's what both things are implementing. To provider, which is our answer provider. And this thing, what it does is, whenever anything requires an answer, in this case, it goes through the provider, and because the provider knows the context of the class it's injecting into, it can do different things. One fairly common usage for this thing is when you have logging, you need to create loggers with the names of the classes where you are logging from. You want to somehow identify them later on so you can filter the logging statements. With this thing, you can just inject logger, and you have the logger is created specifically for the instance it's going to be logging from. But the instance still doesn't really care where the logger is coming from. You can have one global one, or you can be supplying logger per instance with some additional things and so on. So this is like more advanced factory where you can hide the context as well. So the class, if we look at Jerry doesn't really know, it just injects an answer. It doesn't, there is in the test, if I quickly find that, and that is number 1. There is here questioning Jerry, which just depends on an answer. It doesn't care where it is coming from or what's going to be the actual type. It is going to be whatever you decide to be, and that provider gives you the power to make any decision without needing to change anything in the implementation of your business logic, for example. So the Jerry can do things with that answer without knowing that it's going to be insult or whatever. So the dependency providers are fairly powerful. You just have to know when to use them and for what. There are a couple of problems that are really easily solvable with this, but you can shoot yourself in the leg as well when you overcomplicate things. But all right, that was extended exercise 1 with mappings. There are not only methods that are map something dot to something, but there are those method calls which are like a single method call that doesn't create the fluent interface object. You do map to class, map to value, and so on. The interface is pretty much identical to just putting those two standard calls together into one. The thing why this exists is this is in a dependency injector interface, and the whole Hex Machina is using this interface. So when you want to start using just the injector with this fancy fluent interface, you can. It's easier to start with, the code is easier to read as well, but then we would be exposing internal objects to the outside as a part of the interface, and we would clutter the dependency injector interface with unnecessary things. So there exists this set of methods which are used everywhere. Like throughout the whole framework, it is using only this. So if you want to replace the injector within the framework, you can. You just need to implement an interface, and suddenly the whole Hex Machina will just start working with different injector. Your injector, perhaps. There are limitations to those things. Those method calls that are on the screen and the ones that I explained before, they take in a class as the first argument, which is nice, but not everything in Hex is a class. For example, you can't map int this way, because int isn't valid Hex class. Hex doesn't recognize it as a class. Same thing with bool and string. So for that reason, there is a map class name method where you just put there a string, and that's it. Fully qualified string of whatever you want to map, and it will just work. It has the set of methods that I showed before. So map class name .to. And it has the same set of methods that are in that interface. So map class name to value, map class name to name, to singleton, and so on. Those are there. This thing, yes, you can map anything. It's going to work, but it's a bit of a pain to maintain that because you have the class name as a string. So refactoring will not work on the strings. You need at least not the Hex developed one. But there is more syntactic sugar. There is this injector util, which you can just using injector util, which adds to injector another set of methods, which are map dependency, and again it's map dependency .to whatever or map dependency to whatever. Like all those sets of methods are there, and this is using a trick where you can in the generic. So there is this new dependency of t. In that thing, you can put anything, including the string, including int, including enum, whatever you want. and the macro underneath that will transform this call into this call. So you don't have to worry about strings, refactoring will work, you can use imports, you can drop the fully qualified class name and have that mess all over the place. You can just use this map dependency. Excuse me, and you will just it will just stringify the name for you at compile time, and it will work as well. For this, having exercises would be pretty much useless because those are exactly the same things, except they work slightly differently. So we know how to map things to the injector. Now it would be great if we learned how to actually get them from there. So the first way we're going to look at is just direct calls to the injector. So assuming you have access to the injector, you can just start asking it for instances. The most common way is just injector get instance. You provide a type or an interface of what instance you want, and injector gives you back an instance, or throws exception if there is no mapping. You can optionally, there is a second parameter which is a name. You put there the name as string. So here you see how it comes together when you map things to a name. Here you can request with a name and you're talking about the same instance. There is a handy method that you can use if you just want an instance, regardless of mapping, which is called instantiate unmap. And that basically, if there is a missing mapping, it just gives you an instance anyway. It just builds one, always. And it actually skips the mappings as well. So if you have something mapped and you ask for an instance of that thing that is mapped, it's gonna ignore the mapping and just build you a new instance. Really, like, gives you a new one. And you can be sure that you have a new one. You don't share the instance in case if it's singleton. You don't share the singleton, you get a new instance. Then there is this even handier method called get or create new instance, which is basically a combination of the first get instance and the second instantiate unmap. Basically, you need an instance, and ideally you want the instance that everything else has, but you can live with just having any instance. So this call internally, it actually checks if the instance, if there is a mapping in the injector. If there is one, it will provide you the instance based on the mapping. So whatever dependency provider you have there, that's going to return it. And if there is no mapping, it will just make you a new instance. Anyway, so you will end up with having something. Yes.
And this new instance won't be mapped.
It won't be mapped. No. So you can from multiple places request, and it's always going to build you a new object for every request. There is many times it can happen that you have instance that you somewhere created. It has its dependencies. And because you are manually creating the instance, you want to still use the power of injector and put more dependencies in there. That's handy if you're using annotations. So you can manually call inject into, and in this case you are providing an instance, like any instance of whatever. You can call injector inject into that, and the injector will try its best to satisfy the dependencies. All right, exercise number 2. So here we will actually be creating the objects from the injector and requesting them. All right, so Rick somehow misplaced his portal gun, or probably it was Morty who did that. And now we need, it's still somewhere in the injector, it's just, it was assigned to now or something. in the Rick instance that is coming in the argument. So well, first we can try to cheat and just return new portal gun without actually doing anything, because this asks for a portal gun. So this is test-driven development. We can try that, and the test will still be failing because it's not the portal gun. It's just something that was just created here. Yes. So we can't do that. So we can just say, all right, so return injector get instance. Yes. So you can do. So if you return now the instance, the test will still not be passing, because yes, it is great, now you're returning the portal gun, but Rick still doesn't have it. So that's also not ideal. So you can assign to the Rick's portal gun. So we get the Rick. The portal gun is the injector get instance, which will pass the test, and then if you return the Rick portal gun, it's gonna pass, because this is absolutely valid, and this is actually what the injector is doing internally. And the thing is, now when we start having multiple of those dependencies, so we have, like, now it's just portal gun, but it can be 10 different items, and satisfying them one by one is rather annoying. So you can do inject in, you can use inject into, and the injector will just do all the heavy lifting and assign properties to all the, we're still here, and assign everything. So you can just do injector dot inject into Rick, and you're done, and this way you suddenly don't care about the internal dependencies of that object. It just, yeah, it has some injector, please deal with it, it's done. Like, injector will just take care of everything for you. All right, so let's move on to the second exercise, and that is we need to be creating humans based on whatever Rick wants. So Unity is a special entity that possesses populations of entire planets, and it can do anything with them. And Rick is partying with it, and suddenly he has like weird requests that he wants to see all redheads and so on. So like Unity will just start supplying some humans, but you don't know the requirements. The easy thing would be here, well, it is a factory, so you can just return a new human, right? You can just create new human and inject into it. So like, yes, there is a human, and you can just inject to it, but you quickly see that this constructor actually it doesn't have anything optional. So if you look at the, exactly, so not enough arguments. So all the arguments of this human are actually in the constructor, and you don't know them here. So you would have to be asking, all right, so injector get instance of gender, get instance of hair color, and so on, and do all those things is again getting rather annoying, and inject into will not work for this case because you need to construct the instance. But you can do instantiate unmapped, because that can deal with constructor injection and create an instance for you with all the dependencies that are already existing in the injector. So now we would rewrite that. Instead of creating new human and injecting into it, we just do injector.instantiate unmapped, and that's it. Right, and we just return exactly that expression, and that's it. So this is here to show that even though the instantiate unmapped might look redundant, because you can always create new instance and inject into, but when you are creating a new instance yourself, you have to deal with constructor. When using instantiate unmapped, you don't have to deal with constructor. The injector will deal with the constructor as well. So it can have constructor injection, and the injector will just take care of it. So the test will now start passing.
16. It was 18 before.
Yeah. So there is, because you can map things in, you can have multiple mappings with the names. So this next exercise illustrates the named mapping. So we can just injector get instance of Jerry with the name, and that's it. Because the mapping is to name, we can this way obtain whatever instance it is based on the name. So, for example, if you try to return Jerry without a name, the test will be test will not pass, because you're returning a different Jerry. Like, it's not the one you actually want. You need the one with the one specific one, the one with the name. All right. Move on to next exercise. In Rick and Morty world, there's this thing called Plumbus. Nobody really knows what it is, but everyone has one, and everyone is really happy with it. We also have a video for that. We can play it later on. It is let's watch it. It's entertaining. It's Friday, so why not? We even have a music. So.
Today on How They Do It, plumbuses. Everyone has a plumbus in their home. First, they take the dingle pop and they smooth it out with a bunch of schleem. The schleem is then repurposed for later batches. They take the dingle pop and they push it through the crumbo where the fleeb is rubbed against it. It's important that the fleeb is rubbed because the fleeb has all of the fleeb juice. Then a schlomby shows up and he rubs it and spits on it. They cut the fleeb. There's several gizzards in the way. The blamps rub against the chumbles, and the plubus and grumbo are shaved away. That leaves you with a regular old plumbus. I always wondered how plumbuses got made.
Right. So this is a plumbus. Think of it whatever you want. That's what it is. So because everyone has one, and suddenly looks like your neighbor doesn't have one, and he wants it. So it's up to you to just not look like idiot and just return anything. So in this exercise, you just need to return a new instance, regardless of whatever's happening. You just don't want to be that idiot who doesn't have that. So you just get or create new instance, and you make sure that your neighbor looks stupid, not you. So yes, get or create new instance of plumbus, and this thing should now start passing. All right. So now we know how to get the dependencies manually yourself, and you can manage everything with the injector. But of course, there is much better way. There is a automagic annotations feature where you just annotate pretty much anything at this point, and it will return you an instance automatically upon creation. So hexInject is the standard is a standard annotation which is used not only by Hex Machina, but minject uses that, and pretty much everything else. Most people use the dependencies using public variable because it's convenient. So hexInject public var of whatever type, and Injector will just try to do the best and put an instance in there. Optionally, in braces in parentheses you can put there a name, and then it will just use the name. There are in Hex Machina there are utilities to avoid this name as a string there. We have a util that if you implement another interface, it magically will start supporting constants. So you can put there a constant, and it will search for the value of the constant and replace it with the actual value. So it will produce actually valid code, but its macro magic will just do that. I think for injection, you don't even need the secondary interface. It will work out of the box. So you can use there my constant whatever, and then you have the power of refactoring again. You have the constants all over the place. But you can use only constants. Like it's not gonna try to resolve and recalculate anything. Like it needs to, whatever variable is there, it needs to point to a constant string basically, and that constant string is basically copied back to the original metadata. So the compiler works, because if you put the constant in the metadata, it's not a valid hex expression. It's actually not going to compile without the macros. And another annotation is optional, and it is basically, it makes sure that if the dependency is missing from the injector, that it's just not going to be injected. So you can, if you have hexInject public var, if the dependency is missing and you are constructing that object, you're gonna get exception. Missing mapping, like deal with it. With the optional, if the mapping is missing, no big deal, it's just gonna stay null, and nothing's gonna happen. No exception is thrown. There are multiple injection points that are supported currently by Hex Machina. In other languages and platforms, the most popular one is the constructor. You just annotate add public function new, and it will take care of all the arguments. Then there is public variable. I talked about that one. You can also use mapping injection point as a function. So it will call the function with the arguments that are actually the dependencies, which you might ask, why would anyone want to do that? It's very handy if you have legacy code and you have like set init, and you pass in an object, and then something is done on that object, and some stuff from that object is stored into internal state. You don't need to rewrite any of this. You can just slap hexInject in front of the method, and then that method is called with your init or config that is maintained by the injector. It's just gonna get called, passed in, and everything happens in order. So you don't have to deal with, like, you don't have to move that code to a constructor or somewhere else. You can just call inject into, or let the injector deal with it, and it's going to call the method with the proper argument. And setters are of course also support it. You just annotate the variable, and if you have setter, the setter will get properly called, and everything's gonna work there as well. One thing to note, there is this optional and true in parentheses. The true is optional. So when you're annotating public variable, you don't have to have the true there. But it is very handy if you are annotating arguments. So constructor can have optional dependencies. So you do optional true, false, true, false, true, false, and it will map to the arguments, and based on that you will get either null or not null dependency based on like however the providers are looking. There is one thing you have to do in Hex Machina that you don't have to do anywhere else, and that is implement this injection container interface. This is magic interface. It doesn't have any methods. You just have to implement that, and it has a built macro attached to it. So everything to make it work, the basically hexInject is using its own reflection. It's not using the standard reflection, which is slow and annoying. hexInject actually pre-reflects all the annotated expressions and stores them in a data structure. So afterwards it just does one reflection call to collect all the data and everything that needs to be called, and then executes the whole thing. So in theory that should be faster, but anyway the injection doesn't work without this this interface. All right, exercise number 3. Let's do this. So in this one, we're gonna do multiple different ways of injecting things. I didn't really bother creating different to-dos for everything because they are virtually the same. So in this one, we need to inject a portal gun through a constructor. So I guess that's not that hard to just create a constructor argument of whatever portal gun of type portal gun, and and you do at inject, and that's it. You need to save the portal gun and so on. There is again, if you do Control-Shift-1, private field, yes, and then you just return it in the get portal gun function, and that's it. So this one will start passing, because also we have implemented the injector container, which is important. So let's move on to the other files. Function is pretty much yes, exactly. Function is pretty much the same thing. You just need to create a new function. No, you can try this. It's not gonna pass the test because the test is checking whether or not you're returning the proper portal gun. You want to change the not the constructor, but use a method. Yes. No. This is getter. You need to inject on a method. No, this is still getter. Yes. You need to create a new method. Or whatever. That's the point. Method doesn't matter. You can name it however you want. It's looking only at the metadata. Yes, this is a method. You need to give there the stuff you actually need. Yeah, whatever. Yes, you keep this and you return the portal gun in the get function. and that's it. So this test will now start passing as well.
9.
8.
Yeah. There's a lot of assertions. Yeah, and the last one is the yes.
Just a question. Is a method from outside it's called with a portal gun instance or without and the inject knows?
With yes, it is called it's just standard method call with that instance supplied coming from the injector. So what actually happens is injector gets all the dependencies that it needs for the call, and then it calls with all the instances that it gathered.
From outside.
Yes.
From outside.
Yes.
Let's say I have my class and I want to retrieve a portal gun. So let's assume that I call it is a method.
Yes.
So this, so I call the my instance dot is a method. You know?
No, that you are not calling this method. Injector does that.
Okay.
So-
So I just.
You do just inject into and you don't do anything else.
You probably it will be easier if you show the test. There's like
Yes, exactly. The test is for most of them. We're number 3, right? For most of them, the test is pretty much identical because there's so here is a function, and as you can see, here is no method call. We just instantiate unmap, and that's it. Like the method actually gets called automatically by injector.
He knows that he need the instance of portal gun.
Yes,
to
yes,
go-
exactly. The order of operations is actually it first constructor, of course, then it does all the public variables and properties, so the getters and setters can be mixed with just normal variables, and then it does all the functions. So you can have a function call. You shouldn't really depend on the order of execution. For that thing, there's another annotation which I get to later, but the function is called by the injector internally, so you don't have to worry about it. You can easily like move all the legacy stuff if you have it to just annotate things and move them off. Like you can delete those calls because injector will do them for you, supplying the objects that are now managed by the injector, and this is a fairly easy way to refactor code base and start isolating the problematic parts by just slapping at inject everywhere. Injector will just deal with it, perfect, and that's it. So yeah, there's no function call from you as a user side at all. The injector does that.
Nice.
Right, and the last one, public variable. Not sure if we should go through it or not. It is essentially the same thing. You just create public var and annotate it with @inject, and that's it.
And the injector create a new instance and put it on import event.
Yes, exactly. So what injector does is basically it creates new instance and then it calls inject into. And inject into does it traverses through all the properties that were reflected beforehand. For that you need the interface, and it just keeps assigning until it's either done or there is something missing and it's gonna throw exception. If you have optional dependency and you're missing something, it's just gonna assign null. No, it's not for public properties. It's not gonna touch it. Like if you are so for example, you can do this, or you can have optional. And when you have it optional, for public properties, it's not going to touch that thing if the mapping doesn't exist. So it's not going to rewrite you anything. You can have default value there. So you can have optional and something with a default value, and the injector is going to skip that. But for a method calls, because that's still injection point, it still needs to do something. So it actually does the method call with null. If it is optional and missing, it's going to call the method with null, because you might have like one optional and one not optional argument in the method, and you still want that thing to be called because there is one not optional. So the injector, it doesn't really check if you have like everything optional in a method or just something. It's if there is the optional annotation, it will just always call it, and it will either provide nulls or actual instance. So if you want to use method and you want to do the optional, you should check if you are receiving an instance or not, because it might be null. Yes.
Question. If a parameter is not optional and is not mapped, does the injector create instantiate map?
No, it throws exception.
Okay.
You get runtime exception because that's clearly a mistake in your code, that something depends on something and you are not providing that instance. Using the instantiate unmapped or get or create new instance, you should be using it basically when you know what you're doing, when you have exactly purpose for doing that. Otherwise, it's always better to get the exception and deal with it better earlier than later, because one missing dependency might mean some crash somewhere. So the injector doesn't do anything automatically for you. You have to explicitly ask it. All right. So far, any other questions? All right. So let's move on. So we now know how to inject things. That's all nice and handy. But if you are using public variables, you don't know when all of them are there, for example. So you need something to deal with, to let you know that like everything is ready. Because in case of constructor, it's fairly easy. You have like all the arguments in the constructor are there because they have to be, so you can just work with them. But if you have public variables, you can't work with them in constructor because that constructor is called before it starts assigning, and you don't know when it's done assigning things. So for that, there is this post construct annotation. You can annotate any method with it. Again, name doesn't matter. It's just as long as it is function, and it will get called after all the @inject stuff has been processed. So it will assign all the public variables, call all the @inject functions, and then it will call post construct. Like injector is basically saying, I'm done with you, just now everything is ready. And for you, that's the point where you want to start doing some logic, basically. That's like the second constructor where you know that all the dependencies are actually there, that all the assignments already happened, and you will not get, hopefully you shouldn't get any null object reference because everything is assigned. One remark, it is considered as injection point. So it has same importance as the @inject. That means if you call inject into, it's gonna call the post construct again as well. So there is one practice that I saw that you have various properties as optional, and you have multiple injectors, which each of them has different subset of the properties. And you call inject into, one will supply one set of dependencies, second one will supply another set, and so on. But then you have one post construct call which is called like 3 times. So you have to account for that. You have to know that this is gonna happen. Otherwise you're gonna be confused why the hell it is calling after the instance is constructed and so on. So this is really powerful, but again, you can shoot yourself in the leg by not caring about how many times the inject into happens. And what gets constructed has to eventually get destroyed as well. So the pre-destroy annotation, again, you can annotate any method. Currently, only supported dependency provider that does that and for which it makes sense is the singleton one. So when you unmap a singleton, it will call a pre-destroy method for you as well. So when you have an instance that you mean to use as a singleton, but it's, say, a network connection or something like that. So when you unmap it from Injector, you want to cleanly destroy the instance by itself. So that instance is using pre-destroy and it can close the socket, for example. Because it knows that, like, all right, now I should be really disappearing. I'm unmapped from the Injector. This is there is no life after this, and the instance is gonna get garbage collected. So for that, you use pre-destroy. Both of those functions, you can have more of them. The annotation takes optional parameter in just parentheses. You can put there integer, any integer basically will work, and they are ordered. So you can say post construct 1, post construct 2, post construct 3, and they will be called in that order how you number them.
Why is it good for?
That is good for example, you could have, again, working on a legacy code base, you can deal with the order of executions where you had where you had to call in order something. So I don't know, initialize, prepare or connect to server, and I don't know, let's say create a single client and send it to server. And your legacy class had all those methods, and they were all called in the same order from somewhere from the outside. And they were called, of course, after the dependencies were all there and everything was ready, and then they were called. So again, you don't want to create a new code, put that code somewhere and put them in order and so on. So you can use the post construct and use that thing as like, all right, so when I'm constructed, then I will just order those methods and they will get executed based on that. So for example, it's usually, I haven't seen much of a usage of this feature, but it is usually supported by every injector, so we have it as well. All right, exercise 4. Surprisingly, it's going to be about the annotations. So yes, Rick and Morty are escaping from intergalactic police. They need to both teleport themselves, but they need a portal gun. And you need, like at this point, you basically need Rick with his portal gun, and you need Morty as well because they're running. So you inject both of them. Yes. Yeah. Now the thing that is handy is that the injector deals with the whole tree of dependencies. So as you saw, Rick injects a portal gun, and in this case you just don't care about the portal gun. You inject Rick and you just assume that the injector did its job, and it also injected whatever was needed for Rick. So at this point you know you're getting ready to go instances with all their dependencies supplied as well. So at some point you might run into a bottleneck that this takes long if you have many dependencies and things depending on each other and so on. that usually in the beginning of the application you have a freeze because it needs to construct all the objects for all the objects, and it just builds it up from ground up until you just have your one line of new main, and that's it. So yes, in this case we need to wait until everything is ready, so until both things are injected. So we need the post construct method. So whatever, usually people name it just that way. It needs to be public, otherwise it's not accessible by the injector. Like, that's mild disadvantage. Everything has to be public because otherwise the injector doesn't have a way to call it. Like, it needs to be able to access those properties. So you can't inject into private variables or do any private calls. And yes, we just use that hint call. And yes, Rick is there. Teleport with Morty. Just Morty, yes. So this will start passing again. Actually, no, it's not passing. And the reason why it is not passing is we're missing the magic interface. Because, yeah, in the previous exercises I've included the interface, so you might miss it, but those exercises, they need that. So really many times you just forget about that interface, and then nothing's happening because the injector just doesn't see the stuff pre-reflected, so it doesn't look at the reflection data, and it just, for him, it's just, yeah, it's an instance with no dependencies, and it just gives you a new instance and nothing is injected ever. So this interface is really important. Yes, so yeah, this is now passing. We can switch to the other one, and if you zoom slightly, yes, implement the magic interface.
Excuse me.
Yes.
Why didn't you use the annotation approach instead of implementing the interface? As far as I understand
the interface is more convenient because with the annotation you would have to either attach the build metadata to everything, or we would have to use something like type crawler to go through everything. But the problem is that you might want, if you have large code base, crawling through all the types and checking if any of the members has some annotation, that might add, or that will add to the compilation time. So this is how the interface actually looks like. There's an auto build, which is a macro that is automatically called on anything that implements that interface, including children of things that implement that interface, including things that implement interface that extends this interface, and so on. So like literally on everything that should be reflected will be reflected. But you have to explicitly say that you want that thing to be reflected. All right, let's get back to here. This one is, there's a planet. So they were escaping from intergalactic police. They got to a planet, but the planet is about to get destroyed, as it happens in their adventures. So they need to escape from there, but not too early, because the police might still be looking there. So they need to escape at the right moment, right before the planet gets destroyed. So for that, we will use the pre-destroy metadata. So they can stay on the planet as long as they want to, but before it gets destroyed, they want to be sure that they will escape. Yes, you need pretty much the same stuff. And you need a pre-destroy function. with the proper annotation and just the same teleport call like it was before. Alright, so this will now start passing as well. Two more assertions to go. Any other questions so far to this? No, perfect. So then there is one more thing that I want to talk about today, and that is stuff that we call mapping definitions. It's basically a type def, which is meant to represent a way to define the mapping without actually having the injector. Now, why would you want that? It is very heavily used in DSL, which Laurent will talk later. And basically, this allows you to create set of rules for the injector, but for the injector you don't have. You can just expose the rules. So you have a module that just says, well, if you have injector, I want all this stuff to be mapped exactly this way. So you can say, all right, there's going to be this instance of something, it's going to be singleton mapped to this interface, then there is going to be something else which is mapped to a value, and so on. So you can create all the mappings and then pass them all at once to an injector. An injector will just construct all the mappings as well. So that is handy if you don't know if the target thing has injector or not, or if you just don't care. And also it is handy when you need to replicate things. So you have one injector, or you have one module and you want to replicate its behavior over multiple injectors. So you can take all the mapping definitions and stuff them one by one into each injector, and they will all behave the same. So mapping definition is basically just type def with most of the stuff optional. So this is how the type def looks like. I will go through all the properties. So there is the from type. It's a string, and it is basically the from type is, if you do injector map, there is the from type. It has to be string because, again, we don't have syntactic sugar for that yet, especially for the DSL. So you need to provide the fully qualified class name of what you want to map. With name is another property that just puts there a name, pretty straightforward. And then the to class to value, they're using the same calls for the injector. Then there is this S singleton, because you do to class as singleton in this case, in the mapping definition. So you don't there is only class mapping, which you are mapping basically type to type, or instance or value mapping, which is type to value. And if you want it as singleton, that is a boolean, so you just mark it as true, and it is singleton. Then there is this inject into property, again boolean. This one is useful, and it is used only for the value mapping, and that is, you prepare your value, and you want the target injector to inject into your value as well, because it might be depending on things that you are mapping there, or it might require things from the other injector to be actually injected. So that's what the inject into does. Those mapping definitions are handy, but because they are compact, you can put them in array, and then you're just passing around one array with all the definitions, and everything is nice and easy. But the problem is that there's that string, so you can't avoid typing that string and then having the obligation to maintain that string because refactoring will not work and so on. And it can't do the dependency providers yet, I think. We will add that one as well. So currently you can't supply your own dependency providers for the mappings through the definitions. All right, last exercise before a break. So now we need to create basically instructions for a universe to be complete. So every universe needs a one rake. So create an array. Just square brackets. Let's use hex. All right. So first will be, you can just write anonymous objects exactly. It's going to be from type rake as a string, and you can copy it from imports. So this is rather annoying about the mapping definitions. It's gonna be, what do we want? Only one. So a singleton true. And it's gonna be to class Rick. And here you can provide, yeah, this takes actually class type, so you can put there class. Yeah, another one, Morty. Mortys are expandable and nobody really cares about them. So you can map it to anything. Yes?
So why we need to from type to class because this is like previous, you know?
Yes. Yes, it is basically this is the same thing as creating the mappings manually.
Yeah.
But in this case, you don't have the injector, so you don't create the mappings, you just create the instructions. And then some injector, I will then show the test. So map it as just to class without singleton. So yeah, I'll show the test, which is using another util to quickly map everything to a single injector. Yeah, again from portal gun, and it's gonna be again a singleton. Yeah, this doesn't have autocomplete either. Oh, yeah, you moved somewhere. And last but not least is going to be meseeks, which is again from type meseeks to class, because we want the instance to be always created a new one, because it's a meseeks box for pressing.
What about your first mapping? It should be not value not class.
Yes, true. We're getting break in an argument, so that should be to value without any singleton, because that's ignored. If you're doing value, then it is to value. And now that we have this, in this case, it's still not gonna work. You can try it, because still failing, because it's not, the portal gun needs to be injected. So you get rake, but it needs the portal gun, so you have to use inject into for the rake. The first line So you do inject into true. And now the item will get injected. So now everything is passing. One thing to remark about this is that the order doesn't matter. So the mapping definitions are respectively the order of execution is sorted out for you. So when you have inject into, you want that thing to happen after all the things are mapped. So in this case, it will map everything and wait with that inject into call after everything is mapped. So even though the inject into is in the first item, the utility will just deal with it and actually inject into after everything is properly mapped.
And it will also serve a situation if, for example, I will have 2 weeks, right?
Yeah.
And both of them will have inject into, but they need 1 week to be in pocket of other week, no? So you see what I mean? So I have 2 objects,
Yeah.
which requires inject into, but also one of the objects requires other objects.
Yeah, that is
Also that.
yeah that is possible. Because or you mean you want in one object you want the other object to be injected into
For example,
to be injected in.
for example, for portal gun we will need some
Yeah.
portal liquid.
Yes.
Right? So portal gun will also have like inject into true, but portal gun should be injected into Rick as well.
Yes. This order isn't kept. So it isn't maintained. It's first things are mapped and then they are injected into. But it's not calculating in what order they should be injected into each other.
Okay.
That thing it's not doing. It is something that we definitely want to look at because you might run into trouble with circular dependencies, for example, which is exactly what you described. So yeah, we don't have any detection of circular dependencies there, unfortunately. But Francis will work on it.
Yeah,
Yeah.
it's busy now.
It's-
We already
yeah.
discussed about it to add it here.
Yeah, it's on our massive to-do list. Yeah, I wanted to show the test. Yes.
In case you get a circular dependency, what would currently happen? Would it just
Probably Stack Overflow.
okay?
Like it would just run onto oblivion and
Okay.
it would break definitely. So the way here is the nice trick. So there is another util that exposes this method on the definitions. So you have the array of your mapping definitions. You just add to injector and it will just go through them and that's it. It supports more things, but that's not going to be covered today. And I believe that is it for the part 1. So yeah, let's have a break, and then we will jump into the DSL, which hopefully will be more fun, but it's going to be using a lot of terminology from what we just went through. So that's it. I don't know, 10, 15 minutes, 15 minutes. Yeah.